Okay, so we're picking up with slide 19. You may have some stuff written on there already, but we're going to add and fill in the rest of it. All right, so again, just to review, we start with, in these differential equations, we start with separate, then we integrate. All right, then it's solve. But what we solve for, we're going to solve for C before we solve for Y. All right, we're going to solve for C first. So that's going to be the change here, and you can only do this when you have extra values of numbers given. That's called an initial condition. So you'll be given a value for X, a value for Y, and that allows you to solve for C. Okay, then we go back to I, and now I becomes isolate. And that's just another way to say solve for Y, but isolate sounds good. So separate, integrate, we're going to solve for C now. Then we're going to isolate Y. And then our final is to select between plus and minus if necessary. So if you have a plus and minus in your answer, you'll need to choose one or the other. And you got to choose the right one. But it depends on your initial condition. So you wouldn't have been able to do that unless you had an initial condition. Okay, so SISIS is the acronym. Yeah?
So you get the C before isolate Y?
Yes. You could get the Y before you do the C, but the math is a lot more complicated. It gets really messy. So it's much cleaner to find the C before you find the Y. Yep. I'm just trying to help you do easier math. It's not that it's impossible, it's just a lot easier. Okay, so here we go. So this is slide 20. Okay, we're going to cross multiply to get us going here. So we cross multiply here, so that'll give me 2y and then dy. And then we'll cross multiply the other direction, x dx. Okay, so that's the separate. Everything is, excuse me, very nicely separated for us. So now we're going to do the integrate portion. So we put our integral here. And we'll do the antiderivative of 2y, which is y squared. And we'll do the antiderivative of x, which is 1/2 x squared. And then we have our constant c. So right now is when we are going to solve for c. Okay, so if we're keeping track, we have S, we have integrate, which is I, and now we're going to solve for C. And we're going to solve for C using this initial condition that's given, where values of 2 for X and -3 for Y. So we just do a substitution of those two values into the equation. So Y becomes -3, and X becomes 2. And then we solve for the C value. So -3 squared is 9. Half of 2 squared is 2, and then plus c, which tells me that c must be what value? 7. Very good. All right, then we're back to another I, which is isolate y. So we go back to what the y was. It was y squared equals 1/2 x squared, and now we know the plus c value is the number 7. So we change that. And we want to isolate y. So this is where we get y alone now. And how do we get y alone out of a square?
The square root.
What kind of square root? Plus or minus square root. Okay, square root, just like absolute values, are always plus minus. So y is the plus minus, and you only get one square root. Okay, you don't do a separate square root around the half squared and a separate square root around the 7. It's one square root of 1/2 x squared plus 7. Okay, that's the I part. Now you're ready for S, and S is the final selection. And the final selection, it's like that rose ceremony in The Bachelor, where the bachelor's down to the last 2, and he comes out with a rose and he picks the one. Okay, we got to pick, is it the positive square root or is it the negative square root? And again, we look at our initial condition. And the initial condition is 2, -3. And can you picture where that is on a graph? Where is 2, -3? What quadrant? Can you picture where you would go? Actually, this is the first quadrant, and that's not where 2, -3 is. 2, -3 is right here. That's in quadrant 4. That's considered a negative quadrant because it's below the x-axis, which means my selection has to be the negative square root. So my last S is to select the answer, and it is the negative square root of 1/2 x squared plus 7. So you always make your selection based on the position of that initial condition. So that initial condition allows us to do two things. It allows us, one, to solve for C, and then it allows us at the end to select the correct final answer. Okay, let's try that again. Here's another differential equation with a condition, which means we'll be able to solve for C. So let's start with the separation. dy dx equals, and then when we have e to the 2y minus e to the 2y minus x, we learned that that is written as e to the 2y over e to the x. We reviewed that last week. That's the algebra that happens. And when we want to separate that, we go through our cross multiplication. That gives me e to the x next to dy, and it gives me e to the 2y next to dx. So everything's on the wrong side. I've got an e to the x on the wrong side, and I have an e to the 2y on the wrong side. So I need to clean that up and have e to the negative 2y on the left and e to the negative x on the right. So that's all the steps of separation. Then we're ready to do integration. So our integration, our I, is going to be, okay, we're going to integrate e to the negative 2y dy and integrate e to the negative x. Okay, the antiderivative of e to the negative 2y is still e to the negative 2y, but I have to divide by the number -2 as part of the anti-chain rule. And then on the other side, we have e to the negative x divided by the anti-chain rule of -1, and we have our constant. Separate, integrate. Now my next S is solve for C. And I do that by plugging in 0 and 0 for the two different values of x and y. So when I plug in 0, I get e to the negative 2y times 0, so -2 times 0 divided by -2. And that's equal to e to the negative 0 divided by -1 plus c. This is all an algebraic step. Okay, do you guys remember what e to the 0 is?
1.
E to the 0 is 1. Okay, so I'm going to come up here. E to the 0 is 1, so that becomes 1 over -2. And then e to the 0 on the other side is also 1, so that's 1 over -1 plus c. Or maybe another way to write that, instead of writing the negative in the denominator, bless you, we'll say that's -1/2 and it's -1. Okay, I don't need all that. We'll just write it as -1. Okay, so then what would C be if -1/2 equals -1 plus C? What does C work out? +1/2. Very good. Okay, so SIS, separate, integrate, solve for C. Now I'm next to the next I, which is isolate Y. So I want to go back to what my equation was. So it was e to the negative 2y divided by -2 equals e to the negative x over -1, and now plus 1/2 for my c. And now I need to do the work of isolating y. That means do stuff to both sides to work on getting y by itself. All right, so Sue, what would your first thing be?
So S.
We're ready to get y by itself. What do you want to do to everything? You're going to multiply. I would not multiply by 2, but I would multiply by -2. I want to get rid of this -2 right here. The only way I can get rid of that -2 is if I multiply by -2. All right, now I'm going to multiply everything by -2. This is different than using an ln or an ln or a square root. You only get one of them. The -2, we have as many as we need. So we're going to multiply this by -2, and we're going to multiply this by -2. So all of these things get multiplied by -2. That gives me e to the -2y. It gives me -2 e to the -x. And then it gives me -1 when I multiply. Okay, Leo, what would you do next to work on getting this by itself, isolating y? ln. And we only get one ln per side. Okay, so we get an ln on this side, and we only get one ln on the other side. So that's going to give me -2y equals an ln around the quantity -2 e to the -x minus 1, because you only get one per side. And then I just divide everything by -2, so I isolate y. So it would be the natural log of the quantity -2 e to the -x minus 1, and that whole quantity divided by -2. My last is the selection. I only need to select if I actually have a plus or minus to choose from. And in this case, I don't have a plus or a minus to choose from. I just have one of each. I only just have the one, and so that would be it. Okay, so that's the final answer. Okay, SISIS, SISIS is the acronym. Okay, let's try again. Okay, we're going to separate, integrate, solve for C, isolate Y, and then select. All right, so S here. We cross multiply, and we have dy equals x squared, y squared, dx. So that's not quite separated the way I want. I want my y squared on the other side. So this would be 1 over y squared dy. And now we've talked a couple times today on when is it appropriate, when is it helpful to use a negative power. Okay, we saw earlier times where a negative power wasn't helpful, but this is a situation where it is helpful. Having 1 over y squared is not as good as having erased that and changing it to y to the -2. Okay, that is a better way to do that. All right, so that's separate. Now integrate. So put an integral symbol on both sides. And the reason that's helpful is I can be y to the -1. So remember, the power goes up, and then you divide by the new power. So y to the -1 divided by -1. And then on the other side, x to the 3 divided by 3, and then plus c. Okay, here's where now you're ready to solve for c. So we're going to put in y is 3, and we're going to put in x is 0. And I'm ready to solve for c. Okay, y is 3, x is 0. So this would become 3 to the -1st divided by -1. X is 0, and then plus c. So 0 cubed over 3 plus c is just c. Now 3 to the -1 divided by -1. 3 to the -1 is the fraction 1/3. And then divided by -1 means the answer is -1/3 for c. So separate, integrate, solve for c. Now I'm going to isolate y. I'll move over and do it over here. So that would be y to the -1 divided by -1 equals x cubed over 3, and then minus 1 over 3. I notice that the x cubed over 3 and the 1 over 3 have a common denominator. Okay, x cubed and 1 are both over 3. So I'm going to combine those into a common denominator and then put them both over 3 and write it like that. If they have a common denominator, it's the best way to do it. Okay, now we want to isolate. All right, so Jeffrey, you can pick. What do you want to do next to get y by itself?
Times.
Yes?
Yes.
Times by what?
-1.
Okay, multiply by -1, and we have as many -1s as we need. So we can multiply by -1, and we can multiply this one by -1, and we can multiply that one by -1. That gives me y to the -1, it was
-1/3. No.
negative x cubed
-x cubed
plus 1
divided by
over 3. Okay? Now y to the -1 means,
1 over 1.
almost,
1 over y.
1 over y. Okay? And when something's written like that, again, we see, oh, I started this problem with cross multiplication. I'm going to finish this problem with cross multiplication. So we cross multiply, and we get 3, whoops, 3 equals parentheses negative x cubed plus 1 times y. And y is almost by itself. I just have to divide. So y by itself would be 3 divided by negative x cubed plus 1. And there's no plus or minus here, so I don't need to select between the variables because I didn't have a plus or minus. You're only going to have pluses and minuses when you have square roots or absolute values. That's when you're going to have to pick. Okay, we can forward to slide number, we reviewed all that. Slide number 25. All right, for our last one, this is where you use these problems in real life. Okay, this is a hive of wasps. I have one growing right outside my back door right now. I asked my husband to knock it down and take care of it, but we need to do that before it gets big because, you know, if you don't do that soon, those things grow really fast. All right, so this is another time where you're going to separate and integrate and then solve. And then we also have an initial condition, which is not hidden, but I want you to see where it is. 10 wasps at the beginning. That is called an initial condition. That means the beginning would be 0 and the wasps would be 10. But let's first separate and integrate. Okay, so the separate part is to cross multiply. So that gives me dw equals 1.059w times dt. Now that's not separated yet. Okay, what needs to move? What would you move here? The dt is fine where it is. I don't need to move the 1.059 either, just the w. Yeah, don't move the number if you don't have to. Leave the number there, just move the w. So the w would come over here and be 1 divided by w, and then keep the 1.059 over to the dt. Again, it's not wrong, Jesse, to move the 1.059, but then you'd need a u substitution later, and it's easier if you leave it where it is, okay? That's separate. Now we're ready to integrate. And then we just move on. Just quickly, what's 1 over w dw, the integral? ln. ln, what kind of w? Absolute value w, right. And then what about the integration of the number 1.059? That's just 1.059 with what letter? No. T plus c. And now you're going to find your plus c, and you're going to plug in your initial condition. Again, what does the in the beginning mean? What's 0? Which letter? There is no x. No, w stands for wasps, and we know that wasps is 10. So in the beginning means time is 0. Okay, that's the beginning of what? In the beginning of time. So make sure you put time for 0. Okay? So ln would have a 10 in it, and time would have a 0, which means c is going to be the ln of 10.